folks, we are coming to the exercise 16.3 part 1, and actually we are starting the core of this chapter more or less from here. Last exercise, what did we do? Last exercise, yeah, we were looking at the events and mutually exclusive and exhaustive and all that. Here probably we are doing core probability, which we will require even for the next year. So that's what we are going to do over here. The very first question, very important. I don't know, I feel it's really important. Why? Because it is coming in the 12th standard also. A question of this type is there in the 12th standard textbook also, and it's been asked in the board exam also a couple of times. So I think the whole chapter will be, I mean this whole exercise will be important, but of course certain things are a little trivial. You write a lot over here, so much writing, sometimes it's also required, but then since we are starting this chapter here, we do a lot of writing. So quite a lot of writing and very little understanding only is required over here. But as beginners, we have to write all that, let, that, this and all that. So as the time comes, I'll tell you how it is to be done. The very first question says that which of the following is not a valid assignment. That means what they have given us is, they have given us a table which is full of probabilities. Okay, these omega 1, omega 2, omega 3, omega 7, they are different events. So for a particular happening, so many events are there. You have to check whether the probabilities are proper or not, whether it can be considered for finding the probability or not. Now, if a particular assignment has to be valid, and if these are probabilities, two things that you have to check is, for a particular experiment when it is getting conducted, if there are so many outcomes, the sum of all the events should come to 1. And next thing is that these numbers which they are showing, they are all probabilities. So probabilities can only assume value between 0 and 1. It can assume 0, it can assume 1 also. So the values, two things that we have to check is whether the sum is coming to 1 and whether individual probabilities are assuming values between 0 and 1. 0 and 1 also, as I said, can be accepted. So that those two checking we will do, and we will say whether it is valid or not, the assignment. So let's get across right away, and as I said, it's very important. Somehow I feel like, you know, getting it now is very important because it is coming again in the next year. So let's take this A sub part. We have got these probabilities, omega 0.1, 0.01 and all that. We have to first check the sum, and then we have to check whether the probabilities are between 0 and 1. So let's check the sum. 0.1, 0.01, 0.05, 0.03, 0.01, 0.2 and 0.6. Let's check. 5 plus 1, 6, 6 plus 3, 9 and 1, 10, 1 carries. 7 and 3 is 10 and 1 is 11. I hope everything is okay. Yeah, 6 and 2, it's 8, 9 and 10. Yeah, sorry, 10. So 1, the sum is coming to 1.0, which is 1. And individual probabilities, we have to check whether it is between 0 and 1. Yeah, so when we check, every probability is between 0 and 1. Just check, each one is between 0 and 1. So yes. So what will happen? This is a valid assignment. So we will write over here in the answer, you know, which are valid and which are not valid. Answer: valid assignments. And not valid assignments. So A is valid. Okay, then let's check the B. Now B also, if we add up, you know, see, 1 by 7, 1 by 7, like that, 7 times we are adding up. So denominators are same, so you can add the numerators. 1 plus 1 plus 1, 7 times. Obviously it will come to 7 by 7, which sum will be 1. So and probabilities, they are all 1 by 7. So we know, you know, 1 by 7, when you take the value, it will be 0.1 something. So that will be definitely between 0 and 1. So that is also assigned. So that will come also under valid assignment. Now let's take this next value. 0.1, 0.2. Now we observe this part is correct because everything is between 0 and 1. Now we only have to check the total. Whether the total will be alright, that we have to check. So let's check now. 0.1, whether we are able to do directly, let's check. 7 and 6, 13, 13 and 5, 18, 18 and 4, 22, 22 and 3, 25, 25 into 27, 27 and 128. So it will be A 2.8, the answer. So that is not valid, right? So not valid is C. It's not valid why? Because the sum is coming too high, right? So it's not valid. Okay, then the D part. See, if we carefully see itself, we've got negative values. Negative values, it's not coming between 0 and 1, right? So no. Since this is no, there's no need to find the sum. If you want, you can find also, but it's okay if you don't find the sum. So not valid, right? Then we can take the next one and we'll find the sum. Now here also all the denominators are 14, so you can just add the numerators. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 15. Anyhow it's going to be higher because 15 already greater than 15 and 6, it's 21, 21, 26, 30, 33, 35, 36 by 14. So sum is 36 by 14, which is greater than 1, and of course this is yes, but then that's of no use. So that's also not a valid argument. So C, D and E, they fall into a non-valid category. The others are alright. Okay, so that is how we will say, as I said, I like the nature of the question because it is whatever is important from the 12th standard point of view is something that's worth doing, right? Something that is going to fetch you marks in the 12th standard, it's worth learning in depth, right? So this is one such question, and thus it's so important. Next we can move to the next question, question number 2. As I said, we will be doing a lot of writing. As time passes, there's no need to write so much, but then as beginners we have to do it that way. The question says that a coin is tossed twice. Okay, if the coin is tossed twice, you have to find the probability that at least one tail occurs. You get at least one tail, right? So as usual, we'll start with the sample space. Whatever they have asked us, we will call, we'll give it some event name. We will try to list that event. Then we'll try to get the number of items in that event. Then we will try to get the probability from there. That's how we proceed, right? So let's start with let S be the sample space. And because we are tossing it 2 times, so it will be like this: HT, TH, TT, HH. This is how the coin is tossed twice. Yeah, these are the outcomes that come up. Now they ask us to find out the probability of having at least, let A be the event that at least one tail occur. One tail occurs. Whatever they have asked, let's assume. So how could A be? At least one tail. So this is one tail case. Yeah, one tail. Then what is the other possibility? There can be 2 tails. So that is this possibility, right? So how many numbers are there here? How many items are there? 3 items. When we want to find the probability by formula, it is n of A. If you want, we could have written here n of S is 4. 4 items are there. So it's always n of A by n of S. That's a formula. So that means it is 3 by 4. Only that much, right? So the required probability is 3 by 4. Correct way to conclude this is required probability. I'm very tempted to write the short forms, but it doesn't go well with everybody. Yeah, so that's about it. Question number 3 is just an extension of this, where they give us different events, and then we have to write their probabilities. So let's continue with the question. Question number 3 says that a die is thrown. They say that a die is thrown. So we know what is the outcome. That we will write, get the sample space, and then individual events we will take, and we will try to find out the answer. So let S be the sample space. And what all things can happen in S, because you are throwing a die. You have all this happening. Number of elements is 6. Then first part, let A be the event of getting a prime number. Prime number. What all can happen? It can be 2, it can be 3, it can be 5. like that number of elements in A is 3. So when we have to find out the probability, it is n of A by n of S, which will come to 3 by 6, which is for the half. So this way we have to find out all the events and then get their respective probabilities. Let's take the second one. I hope it doesn't become too crowded. Yeah, second one is you have to get a number which is greater than or equal to 3. You can get 3, but you can have a number greater than or equal to 3. So let B be the event, required event, right? B be the required event. Now you have to get a number greater than or equal to 3, which means you can get 3, you can get 4, you can get 5, you can get 6. It's a number greater than or equal to 3. So what will happen? Number of elements here that we find is 4. So what is the probability? It is n of B by n of S, that is 4 by 6. You can cut it, 2 2s are 2 3s are 2 by 3, right? I am a bit doubtful about the question, but let me check. Sometimes greater than, lesser than goes the other way around. Yeah, it has worked fine. Now let's take the third subpart, which says that you should find all those numbers which is less than or equal to 1. So let C be the event, be the required event, right? That means you get a number greater than, less than or equal to 1. Now in the dice, which is a number which is less than or equal to 1? There is no number less than 1, but because equal to, you can get at least 1, right? So it's just 1. Like that, the number that is associated with C is 1 because you have only one item there. So what's the probability? Probability is n of C by n of S, which is maybe 1 by 6. You can stop here, but if you want to gain the impression of the teacher, you can write therefore required probability. But of course it depends on how much time you have in the exam and how much mark it carries. Generally each sub question in probability will carry 1 mark. So for that, this is more than enough. It's enough if you do this much. It's enough and more actually. That's about it. I don't know, I wonder if I can borrow some place here. I hope it doesn't get too crowded and all that, but anyhow, taking the risk and I'm borrowing a place from here. And they say that you have to find out all those events where the number is greater than 6. So let D be the required event. Then you have to find out all those numbers which are greater than 6 in a die. There is absolutely no such number because you have numbers only till 6, and the question says that strictly greater than. If they would have said greater than or equal to 6, at least 6 could be included. So D, there is absolutely nothing in D, it's an empty set. So the number of elements in D, because it's an empty set, is 0, and like that you can quickly find the probability. It is going to be n of D by n of S, and that's 0 because it's going to be 0 by 6, and that's absolutely going to be 0, right? And the last, they say that you find out all the numbers which is less than 6, less than 6, 6 is not included, right? So let E be the required event, yeah. Then how do I list E? Every number which is less than 6 is still 5, right? 6 cannot be included, but you have those numbers less than 6. Then you know the number also. Number of elements here is 5. That will quickly give you the probability. It is n of E by n of S. That means it's 5 out of 6. That's the required probability. And that's up with the third question. Because of space shortage, we'll have to stop here, and next bulk of problems in the next video and so on. It's a huge exercise with 21 problems. The problems are quite manageable and simple, but then there is, like, you know, you have to do so much stereotype work and all that. That's about it, and that's about this video. We are meeting with the remaining questions in the next video. Thank you.